Hello everyone, my name is Ron Timmermans. I'm one of the many hosts with the Florida Aviation Network. Today we're broadcasting live and in the clear from FUN Aerospace Expo. This is the 50th edition of FUN, and we're here in Lakeland, Florida. Our studio is actually in the Central Florida Aerospace Academy, and we appreciate their hospitality of letting us set up our temporary studio here today. Throughout the week we have and will continue to broadcast live interviews with aviation personalities and people that are making this whole Aerospace Expo the program that it is. And right now we've got a special guest today who is going to blow you away with some ground training like you've never had before. My guest for this hour is Mr. Diego Alfonso, and a good friend of mine. Diego, it's good to have you with us today. Diego has a very interesting career. He's got so many expert hours both flying and teaching and evaluating pilots. It's quite a record. In 60 years, more than 60 years of flying, he has started out humbly as a Cessna 150 pilot, flying traffic watch in the New Jersey, New York City area, flying 5 hours a day for about 2 years, I think you said, yeah. Building up time. He's flown then as big of things as Hawker jets and Mitsubishi jets and virtually everything in between. 26,000 hours during the 60-year career, almost half of which was flight instruction. He worked for the FAA for a while, and after he retired, he worked as a DPE, a designated pilot examiner, and he's given over 6,000 check rides with various pilots. So you can imagine with this broad base of experience, he's got a lot to offer in the way of instruction, but he's also a very humble person, and he's always willing to learn as well. And we were talking before this interview started, he said, one of the things I like to do when I make presentations is tell people that I'm here to learn. And so he's here to learn today, but he's also here to give us an incredible flight lesson. Diego is an inventor of Alpha Systems, which he'll tell you just a little bit about, and an author of his book called The Theory of Flight 2.0, and it's a portion of this book that he's going to present today in a flight lesson. Diego, thank you so much for joining us today. It's good to have you, and I always look forward to hearing what you have to say. I can learn a lot, and perhaps you'll learn something as well, but we'll all learn from you today.
Well, thank you much for having me, and thank you to the Florida Aviation Network for allowing me to be here. I guess today what I would like to do is I'd like to introduce what I call the flight training missing links, and kind of identifying some areas that I found especially during check rides, that were kind of weak. And to begin with that, let me just go ahead and bring up the following view of the flight training missing link. Okay, it's a unique and aviation safety information program, making our flight training stronger than ever. One of the things that I thought that need to be kind of different in the graphics shown for student pilots is that they were not complete. One of the things I think, in addition to the background of the graphics need to be kind of oriented east and west. The reason for that is that when a student is facing a graphic, the student or the viewer is always facing north, and there is no confusion as to which side the animations go, or the movements. The theory that I put in the book, although a lot of things can be derived from the one theory. The theory is this: when an airplane is flying, or any object that is airborne, the air molecules are always relatively stationary to the object, whether the object is a balloon, a blimp, an airplane, a helicopter, whatever happens. And I almost say rocket, but I'm not a rocket scientist, so I'm going to stay away from that. But so far, in what I've found in our everyday kind of flying, it includes what we know. One of the things that allow me to go down this road is, as I was telling you before, I was addicted to definitions. You probably realize that I have a little bit of an accent. It's almost not there.
You told me I have an accent.
I know. And so I became addicted to definitions. So every time I saw a word that I didn't know the meaning, I would go and look up the definition. And some things just didn't jive. We sometimes define things, and it's really not 100% accurate. So that's one thing. Then the other thing that happened to me was I believe in the personal training. And every time a pilot is in an airplane flying, it should be able to train him or herself. Meaning that if you go on a cross country, do some slow flight on the way. Another 5 minutes is not going to hurt. Do some steep turns. And then when you get to destination, you can do a short field approach, even if it's a 10,000-foot runway. That way you maintain proficiency, and you don't have to wait for the 2-year or the flight review that then you got to brush up to go jump through the hoop. So that was the other thing that happened. I was coming back from one of those runs, the traffic runs, and it was a windy day, and I made a short field approach into a grass field airport in Jersey. And then I realized that I'm indicating about 48, 50 miles on my speed indicator, and the airplane is drifting backwards.
What?
Exactly. The houses were going that way instead of this way.
Yeah.
So that kind of freaked me out. And I started to try to find answers. I asked, and everybody said, well, that's because of the wind. I said, I know it's because of the wind, but why? And I remember that Einstein said, one of the quotes of Einstein's is that if you cannot explain something correctly, it's because you don't know the why of it. And he placed a lot of importance in the why of things. And no one could tell me that. So that got me thinking. And then the other thing is the first time I was exposed to inverted flight with a friend of mine that owned an Aerobot. And as I was flying inverted, I went, well, what happened to Bernoulli now?
Bernoulli, the
Bernoulli
theorist.
is not, now Bernoulli's not on top, Bernoulli is on the bottom. So why are we flying? No one could give me a satisfactory answer to that either. And then I went down that rabbit hole. Thankfully, I was exposed to PowerPoint by a friend of mine, and I started to learn the program, and then I was able to do animations, and that's how I really I think that I have verified this, that wind has nothing to do with flight except one thing: drift. Now, airborne, on the ground, if you're taking off into the wind doesn't produce more lift. What the wind does is allows the airplane at a lesser ground speed to produce the required lift to lift off in a shorter distance. Lift doesn't increase, wind doesn't increase lift on the ground at all. What decreases is the takeoff. That's why normally we take into the wind and land into the wind. But once you become airborne, the airplane doesn't know that wind exists because in my theory, once an object is airborne, it acquires one or two characteristics of an air molecule. It floats and it drifts. And that's what air molecules do. Unfortunately, when we think of wind masks, the word wind masks that action, the drifting of the air molecule. If you look at the definition, the current definition of wind is the movement of air over the surface of the earth, which is correct.
Uh-huh.
But that masks, for us pilot, really what it is. I think that the definition should be wind is the drifting of air molecules over the surface of the earth. That kind of gives a better picture. And so when you become airborne, you become actually a gigantic air molecule, and you're going to go with the wind. But we use terminology that, for instance, relative wind, and we really think that wind has something to do with the airplane flying, when really it doesn't. And while you're airborne. However, one of the ways I try to convince people, I create a scenario. Let's say that there is no wind at all. Calm, perfectly calm. You see a chimney and the smoke is coming straight up. There's no wind. So the airplane is flying and there is no wind. The airplane is striking the stationary air molecules. So that's the initial interaction to touch. What happens after that? We need 2 hours to talk about that. But I need to start deprogramming and convincing people one step at a time. I produced about 3 videos about 2 months ago, and I sent them out, and I got a lot of feedback. Most people didn't get it. Some people got it, but most people didn't get it. And then I realized that I violated one of the cardinal rules of instructing. If you're introducing a new subject or topic
Concept.
or an idea, you cannot begin where you're supposed to finish. That's you got to begin at the beginning. And that's what I realized. So I pulled the videos back. And I'm going to start now a new series of videos where I'm starting A, B, C, D, all the way down. And one of the things that I show is that you can have an airplane on a runway with a 20-mile wind, and the airplane is not feeling the wind. The airplane is not striking the wind, and the wind is not striking the airplane. But you really have to work that scenario. If the airplane is here, and you have a tailwind of 20 knots, and the airplane starts to move in the same direction of the wind, when the airplane reaches 20 knots in reference to the ground, the airplane doesn't feel the wind because it's moving at the same speed as the air molecules are. So there is no wind. Sailors get this because they know when they get that lull, especially when you do an about turn, they get it quicker than pilots do. It's been my experience. So here is a perfect example where there's a 20-mile wind, and yet the wind is not striking the airplane, and the airplane is not striking the wind. Now, if the airplane accelerates greater than 20, now the airplane is going to start striking the air molecules that relative to it are stationary because they're traveling together. You understand what I mean?
I do, yes, sir.
That's exactly what happens when you're up there and there's wind. The airplane is drifting at the speed and direction of the wind and striking the relatively stationary air molecules.
I got
get
it.
that?
Yes, sir, I do.
Now, just to close the picture, if there is no wind and an airplane is flying at 120 miles an hour, the airplane is the one striking the air molecules. The air molecules are not striking the airplane because there's no wind. So now the airplane is flying at 120, striking the air molecules. If the air mass begins to move, the airplane also begins to move with the air mass. And the airplane doesn't know that the air mass has begun to move. That's why nobody has been able to come up with an instrument that could read the wind direction and speed when you're flying dynamically. It has been done electronically. A GPS can tell you your ground speed, and now can tell you with a little arrow, right?
Yeah, it's
but
beautiful.
that is electronic,
Uh-huh.
based on your movement and triangulation. Dynamically, no, because if I'm flying no wind, flying that way, and the wind begins to flow this way, I still indicate the same airspeed because it doesn't touch the airplane. So that is basically, with a very big brush, but you will see that my email will be on the screen at some point. And if you shoot me an email, I'm producing these videos probably in the next 4 or 5 weeks. And I'll be able to send everyone that sends me their email, and I'm not in the business of selling emails. Just want to make that clear. I will send you the videos.
Okay. Well, good. We'll put Diego's email address up near the end of this presentation, which is going to be in a few minutes. I also wanted to mention to our audience at home that if you would like to get Wings knowledge credits for this presentation, you can do that. Stay tuned after we sign off. You'll get a code to sign up and an email address to get Wings credits for this. And so I would encourage everyone to build their knowledge credits and then go fly with a flight instructor and get some flight activities validated and then earn a phase of Wings, which is a significant accomplishment. And if you earn a phase of Wings, it counts as a flight review, that every 2-year requirement that you and I have as pilots. So it's a good way, FAA's Wings Pilot Proficiency Program, to encourage all of us to become safer and better pilots. Diego, so we've covered the theory of flight 2.0 and just a synopsis, or maybe the foundation of your book here. Once we're airborne in an aircraft, be it a helicopter, an airplane, or a glider, or a balloon, we are one with the air. And if that air is moving, we are drifting with it. The air is drifting, we are drifting with it. Exactly.
The reason why that is so hard to comprehend is because we use the terms eliminate the drift, right? When we learn to use the E6B, why do you ask any pilot, why do you use that? Because I'm going to eliminate the drift. You cannot eliminate the drift, ever. You're always drifting. What you use that tool for is to find out how much you are going to allow the airplane to drift so that you remain in a straight line.
Exactly. Compensation for it.
Exactly. But we use the word cancel, eliminate, and some radical terms, kill the drift.
Which we can't do.
And that's part of our thinking. So it's very hard to say all of a sudden, no. You're always drifting. And the animations that I got on this video, I prove that. No matter what, you're gonna, if the wind is at 20 nautical miles from 340, you're gonna drift to the southeast 20 nautical miles, the same direction of the wind.
Exactly. And that is, there's nothing we can do about that.
Nope.
Or stay on the ground, maybe. I guess that would be
That's
one way
correct.
we could do it. But we don't want to stay on the ground. We want to keep flying. And so, obviously, understanding that once we're airborne, we're one with the wind. We're drifting with the wind.
Exactly.
And then if we have to apply some corrective action to compensate for the drift as we're lining up for a runway on with a crosswind, we have to do that and appropriate. So, Diego has covered what we have today and much, much more in his book, The Theory of Flight 2.0, The Missing Links Revealed. And he's revealed a few of them today and more of them.
Can I just say one thing?
Sure.
I'm probably the only author that recommends readers not to buy the book until you watch the videos, because the graphical nature of the book is very hard to kind of visualize that. That's why I'm creating these free videos so that then you can buy the book.
Okay, so and the book will be available through Amazon.
Amazon.
So, Diego, thank you so much for joining us today. It's been a pleasure to see you again and to hear the presentation that you made. Diego Alfonso, very experienced pilot, examiner, former FAA employee and the like. Just a vast wealth of knowledge, and it's great that you were willing to share it with us today. Thank you so much.
It's been a pleasure.
All right, good. So I'm Ron Timmermans with the Florida Aviation Network. It's been good to have you here for this interview. Stay tuned because there are more interviews to follow today and throughout the week at 50th EAA, not EAA, but 50th Sun and Fun Aerospace Adventure. Thanks for joining us.